Thank you, Katharina. Yes, Paul and I are going to talking about confidential containers today, and especially about attesting them. If everything goes to plan, I'll give a brief intro to confidential containers. We'll then dive into our experiences, putting them into practice, implementing confidential containers, and the challenges we observed. And then, as Felix has already introduced in his keynote, we'll present our new product called Contrast, which is an answer to these challenges and offers a solution. And then Paul goes more into deep dive into Contrast and shows a quick demo in the end. So confidential containers. If you take the spectrum of where we can apply confidential computing to our cloud-native stack, then last year at OC3 we presented Constellation, which is pretty much on one end of the spectrum, where we took confidential VMs and we applied them to the Kubernetes nodes of a cluster, and then isolated this entire cluster as a whole from the infrastructure. With the advantage that from the inside, it's just plain Kubernetes. You have everything as before. It's just lift and shift. But it means that the cluster itself is being isolated also from the service provider, and you need to deal with all of this, managing this cluster. On the other side of the spectrum is where we will be today, where we isolate just the individual workload, the container, the Kubernetes pod from the infrastructure by applying confidential VMs just to that pod, and we will see in a second how this works. But this also means that the rest of the cluster is untrusted. That means the control plane and all of the other stuff is untrusted, and this imposes some new challenges. All right, so how does confidential containers work? It's pioneered by the CNCF project with the same name, which basically took the Cutter containers project for applying VMs to pods, and by using confidential VMs provided by AMD-SEV or Intel TDX, we now have confidential VMs to isolate those pods. And this gives us single workload attestation isolation, but with the effect that we can also use just plain containers, no modifications, lift and shift into those confidential pods. And the cool part is we can install it on top of Kubernetes. This all means it also supports managed Kubernetes. And we don't need to include all of this orchestration part of our Kubernetes cluster. While at the same time, we can keep Kubernetes administrators, that means own our own administrators, but also the service provider out of the trust equation here. So yeah, what happens if you go ahead and you'd like to put confidential containers into practice and bring your application to the cloud with this technology? So usually where we start at is we have an existing application, existing deployment, where we have our application existing as container images, and we have a definition, a deployment definition in the form of YAML files or Helm charts, and we pass it to our Kubernetes cluster, which then takes care of scheduling and running it inside our Kubernetes cluster. So what happens if we want to apply confidential containers? Let's assume we have the runtime available. We can deploy those containers inside this confidential VM environment. This is where the challenges that we observed occur. So how can we attest these individual containers and test each and every one of them while they might scale up and down? At the same time, how can these containers trust each other, communicate securely with each other? And at the whole time, we don't trust the Kubernetes control plane. We don't trust the API server, so we don't know that what we passed in, not only our images, but also the environment that are in this deployment files, the environments, the variables, the mount points, and so forth, that they are passed correctly to our container, and they are applied correctly. And also the Kubernetes control plane has some legitimate access to our container. Like you can type kubectl exec and end up in one of those confidential containers. So we need some form of isolation. This is the challenge, and this is where we came up with Contrast, our new product that we present today. With Contrast, the idea is that we solve this challenge of attesting all of those containers in a scalable way. And the first thing we need is a attestation service that is acting as one endpoint for verifying the entire deployment without needing us to deal with all of these individual instances. And then as the second component, we need something to isolate our container from the Kubernetes cluster, from the control plane, while at the same time keep this native orchestration, keep our usual workflow with Kubernetes, but ensure that the cluster itself, the control plane, does not have any access to our pod. So when we flip this image over, this is how we implemented this with contrast, where we run this attestation service inside the cluster, inside its own confidential container, which means we can get an attestation statement and verify the identity and the integrity of that coordinator attestation service. And then we provide it with a configuration file, which we call the manifest. And this contains all of the evidence, all of these identities of your containers and the environment as defined in your YAML files contains this evidence as part of the configuration, and we pass this to the coordinator, which then does remote attestation to all of our individual confidential containers. So once they are all verified, they all pass the attestation procedure, we provide them with credentials so they can communicate securely with each other through transparent mutual TLS. And then the last part we need to solve is how can we now isolate them from the Kubernetes control plane, at the same time verify that the runtime environment, like let's say an environment variable defined in your YAML file, has ended up correctly inside this container environment. And this is where we use a concept pioneered by Microsoft called runtime policies, where without going into the details, essentially allows us to have some form of agent inside this container that enforces the YAML deployment file, as you've defined in your on your deployment side, enforces this YAML file and makes the correct implementation there accessible through remote attestation. So we bind this runtime policy of this container to its remote attestation statement so you can verify it with the coordinator. And then to wrap things up, on the user side or on the third-party side, maybe a user of your application, they can obtain an attestation statement from the coordinator, a concise statement for the entire deployment, which basically consists of the manifest, so you know what's currently running inside this deployment, plus its own remote attestation statement, so you know that the coordinator is indeed has the correct identity and integrity. That's the rough idea of contrast, and now Paul will go into the details and explain a bit more about the architecture.
Yeah, so next we're going to take a brief look at the architecture of contrast. So contrast consists of a CLI, the coordinator, and init containers that we add to our workload. The contrast CLI helps us to generate execution policies that we annotate our deployment with. Next, we use the CLI to generate the manifest. The manifest contains the reference values of our pod CVM images, as well as the hashes of the execution policies that we want to allow as part of our confidential deployment. And we configure our coordinator with this manifest. Our workloads are running inside of pod CVMs. And in each pod CVM, there's an init container running before the workload. The init container facilitates the remote attestation and certificate pulling part. So the init container will send an attestation request to the coordinator, and the coordinator will verify the attestation report based on the configured manifest. If the verification is successful, the coordinator will issue a mesh certificate for the workload and send it back to the init container, and the init container will write it to a volume mount where either the application container or our plugin service mesh component can read it and use it for secure inter-deployment communication or for authentication against the end user. And next, we will see a quick demo of how this will look like in practice.
And first, we are going to apply the coordinator. We have already prepared the coordinator deployment, which is deployed as a CVM, which is indicated by this runtime class. And first, we are going to apply the coordinator. And we have also already prepared a deployment, which is emoji an example application for emoji voting. And it is also running as a CVM using the kata.cc isolation class. And we have added the contrast initializer as init container. which is using a volume mount where the TLS mesh certificates will be replaced, and the app is configured to use these certificates and the key to talk to other parts of the deployment. So now we are running contrast generate, which will generate the workload policies for the different deployments. And this takes a while, and we download the images we want to deploy and calculate the policy hashes. So here we have the policy annotation, which was added by the contrast tool. And contrast also generated the manifest, which is the configuration file of the contrast coordinator and has all the reference values used for attestation. For example, there are the workload policies in there. So next, we apply our workload. And while the coordinator is now already running, the workloads won't start as we didn't set the manifest at the coordinator, and the int containers try to pull the workload certificate at the coordinator. But yeah, that's not working yet because we didn't set the manifest, so the coordinator isn't allowing any workloads. So as a next step, we run a contrast set to set the manifest at the coordinator. And now the coordinator received the manifest and will start issuing mesh certificates for the workloads. So that's why the workloads are now started. And yeah, from that point, workloads can use the mesh certificates issued by the coordinator. And yeah, it's just working as expected. So the set command also gave us the mesh root certificate. We can now use this to connect to the workload in a secure and confidential manner. So here we are using the mesh root certificate to connect to the emoji photo front end. Yeah, and verify that it was actually attested by the coordinator.
This is probably a bit to digest, but good thing is everything will be open source soon, so you can dig into that. In the meantime, you can find contrast in our product pages. You can get in touch if you want to try it out. It's available today on Microsoft Azure AKS. So yeah, if you're interested, get in touch or join our extended Q&A session in the short break following this track. Thank you.